How's it going, everyone? This video will go through a couple of common binomial distribution questions. So here we have the probability of rolling a 6 on a dice is approximately 0.17. So part A asks, if a dice is rolled 18 times, what is the probability of getting a 6 10 times? So here we use the formula for the binomial distribution with x successes and n trials. That's going to be n choose x multiplied by p to the power of x multiplied by 1 minus p to the power of n minus x. Now here p is our probability of success, which is 0.17. N is our number of trials, which is 18, because we're rolling the dice 18 times. So 1 minus p is then the probability of failure, which is 0.83. That's just 1 minus 0.17. And n minus x, well, that's going to be the number of times we fail. So x is the number of successes, which for part A is 10. We want the probability of succeeding 10 times. So n minus x is 18 minus 10, which is 8. That's the number of times that we fail. So the probability of 10 successes given 18 trials, it's going to be 18 choose 10 times 0.17, that's the probability of success, to the power of the number of successes, times 0.83, that's the probability of failure, to the power of the number of failures, which is 8. So 18 choose 10 is 43,758. 0.17 to the power of 10 is going to be a very small number that I'll keep saved into my calculator. And when we multiply that by 0.83 to the power of 8, to the power of 8, that's 0.2252. Now, I'll write down that number just for illustrative purposes, 0.17 to the power of 10. Okay. That's a 0 point followed by 1, 2, 3, 4, 5, 6, 7 zeros. 0.1, 2, 3, 4, 5, 6, 7 zeros, and then a 2. And then we have a 0.2252. So when we multiply all of that out, multiplying those three numbers by each other, what we get is approximately 0.0002. If we want that in percent form, that's going to be 0.02%. That's the probability of getting exactly 10 sixes if you're rolling a dice 18 times. Pretty small probability. That's part A. Now part B asks, what's the probability of rolling no sixes at all? So that means 0 successes. So that's going to be the probability of no successes given 18 trials. So we're going to have 18 choose 0. The probability of success to the power 0 multiplied by the probability of failure to the power of 18, because we have 18 failures. So 18 choose 0 is 1. 0.17 to the power of 0 is also 1. And 0.83 to the power of 18 is 0.035 approximately. So multiplying that out, 0.035, or in percent form, 3.5%. That's the probability of not rolling a single 6 if you roll a dice 18 times. It's small, but it's not incredibly small, like the one we calculated in part A. And then on to part C. Part C asks, what is the probability of rolling at least 1 6? At least 1 6. So this is the probability that x equals 1 or 2 or 3 and so on up to 18. Now we could calculate the probabilities for all of these x values and add them up, but that would take a long time. We could use a shortcut where we say, well, this is just the probability of x not being equal to 0. Well, that's going to be 1 minus the probability of x being equal to 0. And we already know the probability of x being equal to 0. We just calculated it right here in part B. So 1 minus 0.035 is going to be 0.965. 0.965, or in percent form, 96.5%. Not guaranteed, but pretty high probability that you will roll at least a single 6 if you roll a dice 18 times. So that's some basic probability questions with the binomial distribution. For a lecture on binomial distribution, there is a link in the description below this video. So I hope that helps, and until next time.